This is an inclined plane, and this inclined plane is rough, and angle of inclination is theta. That means angle of banking is theta. Theta is the angle of banking with which the outer edge A of the rough inclined plane is raised with respect to the inner edge B. This inclined road is curved. This is an inclined rough curved road which will have the center O. This inclined road is curved road. O is the center of this curved road, and we can denote the radius of the curved road as R. R is the radius of the curved road. This is a car which will be trying to take a turn round this rough inclined curved road. Mg is the weight of the car which acts vertically downwards. Mg is the weight of the car which acts vertically downwards. Now the weight Mg makes an angle theta with a direction which is perpendicular to the inclined road. Mg cos theta is the rectangular component of the weight of the car which acts perpendicular to the inclined curved road. Now we can denote the normal reaction on the car applied by the inclined rough curved road. This is the direction along which normal reaction capital R acts. Capital R is the normal reaction acting on the car applied by the inclined rough curved road. Now normal reaction R is resolved into two rectangular components. Vertical component is R cos theta, and other component, and the horizontal component or the rectangular component of normal reaction R acting in the horizontal direction is R sin theta. R sin theta is the rectangular component of normal reaction R which acts in horizontal direction, and this is the car. And the car will be taking a turn around this inclined curved road, and we can denote the direction along which centripetal force Fc is acting. Fc is the centripetal force which is required for taking a turn around the curved inclined road. V is the velocity with which the car will be trying to take a turn around this inclined curved road. The road is inclined and the road is also rough, and the car is taking a turn around this curved road. Now the car has a tendency to slide up the inclined plane, and kinetic friction Fk acting between the wheel and the inclined road will be acting down the inclined plane. Fk is the kinetic friction, and now though the kinetic friction Fk is acting on the rough inclined road, but we can assume that kinetic friction is also acting from the center of gravity and down the inclined plane. Now kinetic friction Fk acts at an angle theta, acts at the same angle theta with which the road is inclined, and we can consider the rectangular component of this kinetic friction Fk. We have to consider two rectangular components of kinetic friction Fk acting between the wheels of the car and the inclined rough curved road. The horizontal component is Fk cos theta. The rectangular component which is acting in horizontal direction is Fk cos theta, and the vertical component of the kinetic friction Fk is Fk sin theta. This vertical component, or the rectangular component of kinetic friction Fk acting vertically downwards is Fk sin theta. Fk sin theta. The normal reaction under bracket R acting on the car applied by the rough inclined road is resolved into two rectangular components which are as follows: R cos theta and R sin theta. R cos theta and R sin theta. Again, the kinetic friction under bracket Fk acting between the wheels of the car, and wheels of the car and the inclined rough carb road. Inclined rough carb road is also resolved into two rectangular components, and the two rectangular components will be as follows. Is resolved into two rectangular components and which are given by fk cos theta and fk sin theta. Fk cos theta and fk sin theta. Now there are three forces which are acting in vertical direction, and these three forces which are acting in vertical direction are mg, fk sin theta and r cos theta. That's why in equilibrium, if we consider the forces acting in vertical direction, then mg will be equal to the net force acting in the opposite direction. Mg is the weight that is acting in vertically downward direction, and net force acting in the upward direction is r cos theta minus fk sin theta, equal fk, it should be r cos theta minus fk sin theta. Hence we get mg as equal r cos theta minus fk sin theta, which is equation 1. Now the resultant of r sin theta and fk cos theta, that is r sin theta plus fk cos theta, the resultant of the two forces r sin theta and fk cos theta, that is r sin theta plus fk cos theta, provides the necessary centripetal force fk, provides the necessary centripetal force fc for the revolution of the car round the rough inclined curb road, provides the necessary centripetal force fc to the car which is taking a turn round the inclined rough curb road. Therefore fc is equal r sin theta plus fk cos theta. fc is equal r sin theta plus fk cos theta, that is equation 2. Here in the diagram, r sin theta plus fk cos theta is acting radially inwards, and which provides necessary centripetal force fc for taking a turn. Therefore, fc divided by mg is equal to r sin theta plus fk cos theta divided by r cos theta minus fk sin theta. fc is equal to r sin theta plus fk cos theta divided by r cos theta minus fk sin theta. Again, the kinetic friction Fk equal mu into r, where mu is the coefficient of friction. Therefore, Fc by mg equal r sin theta plus mu r cos theta divided by r cos theta minus mu r sin theta, equal r is taken common, sin theta plus mu cos theta divided by r under bracket cos theta minus mu sin theta, equal sin theta plus mu cos theta divided by cos theta minus mu sin theta, and that will be Fc divided by mg, or comma 1 by mg into mv square by r is equal sin theta plus mu cos theta divided by cos theta minus mu sin theta, or comma v square divided by rg is equal to v square divided by rg equal, dividing all the terms by cos theta, we get sin theta by cos theta plus mu divided by 1 minus mu sin theta divided by cos theta, or comma v square by rg will be equal to tan theta plus mu divided by 1 minus mu tan theta. Therefore, v will be equal to tan root over tan theta plus mu divided by 1 minus mu tan theta bracket close into rg. That is the expression of maximum speed with which a car can take a turn round a rough inclined curved road, where r is the radius of the curved road. And mu is the coefficient of friction between the tires of the car and the rough inclined curved road. Mu is the coefficient of kinetic friction, and we get V as the maximum speed or maximum velocity with which a car can take a turn round the inclined rough curved road. Finally, we get the expression of velocity v, which is equal to root over tan theta plus mu divided by 1 minus tan theta into rg. So we got v as equal to root over mu rg. Then we get v as equal to root over tan theta rg, and that is the velocity of a car around a inclined road. Then v equal to root over tan theta plus mu divided by 1 minus mu tan theta into rg. V equal to root over mu rg, v equal to root over tan theta rg, and v equal to root over tan theta plus mu divided by 1 minus mu tan theta into rg. These are the three expressions of velocity with which a car can take a turn around a rough curved road, and v equal to root over tan theta rg. V is equal to root over tan theta rg, that is the maximum velocity of a car for a smooth inclined curved road. V equal root over tan theta rg. Then v equal root over tan theta plus mu divided by 1 minus mu tan theta rg. That is the velocity with which a car can take a turn round an inclined rough curved road. So finally we get the expression of V as equal root over tan theta plus mu divided by 1 minus mu tan theta into Rg.